So the abyssal plains is the biggest habitat type on Earth. They represent 50% of the habitat on the surface of the globe. Bottom of the ocean, between 3,000 and 4,000 meters. These are low carbon environments, which means there's not a lot of food falling through the water column and reaching 4,000 meters. So these environments can't support a lot of biomass. One of the main advantages of mining at 4,000 meters on the seabed is that you don't have to cut down any forests to get to your ore, right? So all that carbon that's sequestered in the Indonesian rainforest that they're cutting down to actually get to the ore, then all that topsoil that they're excavating and disturbing, all of which sequesters carbon as well, all of that is being released. And there's far more carbon dioxide being released from terrestrial mines than would be released from us collecting nodules at the seabed. Because as soon as you cut the forest down, you burn the wood, as soon as you disturb the soil, all that carbon dioxide and methane is released to the atmosphere. We now have a large body of life cycle studies showing that sourcing metals from the seabed has just a fraction of the carbon and climate impacts of mining on land. So the most persistent myth about carbon impacts of deep sea mining is that we will disturb sequestered carbon in the abyssal sediments that will then be released to the atmosphere and exacerbate greenhouse gas emissions. That has been proven to be incorrect for many years now. It's well established in the literature. It's true that the ocean is the biggest carbon sink. The thing is, most of that carbon is actually in the water column and not in the sediments. So what happens at those depths is as the particles of carbon fall through the water column, most of them are consumed by organisms. So that's why most of the carbon is actually within the water column. Less than 4% of the carbon that's sequestered in the ocean is actually on the seafloor. So anything that we're doing at 4,000 meters to release that sequestered carbon, it's a small amount to start with. And there's really no pathways from 4,000 meters back to the surface where this carbon could be liberated into the atmosphere and exacerbate greenhouse gas emissions. The only potential pathway is through our riser pipe in our operations, and we've actually measured the amount of carbon dioxide that's released from our riser pipe, and it's negligible. What the literature tells us is that very little carbon is sequestered in abyssal sediments. Most of it is in shallow water sediments. And a far bigger issue is benthic trawling, which happens in shallow waters. Benthic trawling disturbs far more sequestered carbon and in far shallower waters than any polymetallic nodule harvesting operation would. So that's the real issue here. And that's kind of being projected onto deep sea mining. There's nothing we're doing at 4,000 meters that's going to release carbon that can make its way to the surface through the water column to be released into the atmosphere.